Welcome back to Atman Unlimited. We're back in the office and we're going to make another Fusion 360 post-processor video. I've seen on numerous occasions people requesting to have their post-processor modified to change the point that the coolant turns on. I believe somebody made the comment of, why do I keep hosing down my tool changer and turning the coolant on when my Z is all the way up, rather than initially positioning Z and turning the coolant on closer to the part. So let's review in the post-processor on how the coolant gets turned on specifically, and we'll look at the Fanuc generic post-processor and go over how we can change the point that the coolant does turn on. After that, we're going to switch over and look at a Haas post-processor, the generic Haas post-processor, and show you some of the pitfalls and gotchas that you can run into and why you need to have some very detailed working knowledge of how your machine functions and how it interacts with its G code so that you can modify these post-processors successfully. As I mentioned in some previous post-processor videos, if you do choose to modify your post-processor, please be very careful and test your modifications. This is just for information. It's not end-all be-all guide on how to modify post-processors, and you're doing this at your own risk. I don't have any responsibility for it. So let's take a look at the generic Fanuc post-processor, or Fanuc, depending on how you choose to pronounce it. And we'll look at how the coolant is turned on, and then we'll look at how we can move it to change it after the Z move. On the screen here we have Fusion 360 open, and then we also have the Fanuc post-processor open. Anytime you go to modify a post-processor, don't modify the post-processor that's distributed with Fusion. If you go over to the setup here and you say use generic post-processors, you can click here, and then a file path will appear here, and then you can click this again and say open folder, and that will open a browser window to the folder that contains all of the post-processors that ships with Fusion 360. You can then make a copy of that post-processor file and modify that one. That way you'll always have the original to go back to in case we make a mistake. So here I've already done that step. I made a test folder for this demonstration, and my test folder contains two post-processors, a Fanuc and the Haas, and then my output folder is going to be the same. And if we post this code, we can then use Notepad++. I just like using Notepad++ for my editor. And then here's the code. It's a very simple code. It's just a facing operation so that we can see the nitty-gritty of what's going on here. So the line that turns the coolant on is right here. It's a M08 code. M8 is a common code to turn your coolant on. This turns on the flood coolant. Now notice the location of M8 is before any movement happens. All we're doing here is we're performing our tool change, and we're turning the spindle on, we're setting a work offset, and then we turn the coolant on. So the machine has not moved at all since the tool change. If your tool change position is at the top of the machine, this will turn your coolant on when your Z axis is at the very top of the machine, and you're going to hose down your entire machine. It happens on my Fidel. This is a change that I made to my post-processor as well. What we would like to do is we would like the coolant to turn on after the initial Z movement. So here's the first Z movement that applies the tool offset and moves to the clearance plane. The reason why they turn the coolant on early, some machines the coolant does not start flowing instantly. When you turn the coolant on here, your coolant has to come on very quickly so that you have coolant when you start entering your cut. If your coolant takes a few seconds to get going, you're going to have to put a dwell in here or take some other measure to make sure that your coolant is properly flowing before you enter in your cuts. So now let's go inside the post processor and see how this simple M8 code is generated. And it's a little complex, so bear with me. The easiest way to find out where the coolant is generated is to go to the top of your post processor and search, and we'll search for coolant. Now it immediately took us to a piece of the code that says set coolant tool coolant. Now recall when you set up your tooling, you can tell it either just flood coolant or through spindle coolant. There's a whole bunch of different coolant options that you have. What this is doing is it's calling a subroutine, another section, by the tool that is currently selected, and then it's applying its coolant settings to it. So if we keep searching down the file for coolant, we'll see a function set coolant. So this function here, from here to here, is how the coolant actually gets turned on. And this is looking at, is it flood coolant, is it coolant through tool? Okay, so this section will change depending on your machine to turn the correct coolants on. Here's your M8 code, here's your M88 code. If it's unsupported, it's just going to turn the coolant off. So then let's go back up to the very top of the file again and search for where that subroutine is called. And it's called right here, set coolant. So let's scroll up a little bit and see what section we're in. We should be in the on section function. So let's keep searching up here. It's a big section. So here's on section. Now if you recall in our walkthrough video that we made, on section gets called anytime we have a new operation in Fusion 360. So now that we know we're in the on section, which kind of makes sense, if we go back over to the actual posted code, here's the on section. This is stuff being performed before that set coolant function is called. Here's our actual output of M8, and then we have some post operation stuff. So now the next thing that we need to do is, if we want to make this change, we need to be able to move this line. Now the funny thing is the comment says set coolant after we have positioned at Z. Well, that's not really what it's doing. It's setting the coolant right after the tool change. So we want to move this little block of code to be happening right between this line and this line. Now that's the trick of the problem, is searching through the post processor and understanding where to move it to. So we know that we want to move it right after a tool offset gets called. So let's look in the post processor for a section that deals with a tool offset position. So here's a piece where we got insert tool call, length compensation, tool length offset. So it's checking an offset, modal plane. I'm doing this in real time, so I haven't done this ahead of time. So here's the end of the section, so we went too far now, so let's back up a little bit. So here's your initial output position for XY. Here's an initial XYZ position, and here's your H format. So here's your tool length offset in H format right here. Let's see if there's any other indications of that. Okay, so I'm not seeing any other instance of that, so it's a pretty good bet that we want to put our coolant piece right here. where it is at the end of this if statement and before this motion modal reset. So we're going to put it on line 886. So let's come up to the top here where we had our coolant. Might have to search for it again. There it is. Okay, we're just going to copy this code. Then we're going to scroll down to line 886. That's where we wanted to put the new code. 86 right here. So set coolant. So we're going to try to put it there. Now the other thing we're going to do is we're going to find the first instance here. We're going to comment this code out. So we haven't deleted the code, we just commented it out. So we'll save our changes and then let's see if they work. So we'll go back over to Fusion, we'll say post process, we'll select the post processor we were editing. If you do make your own, change the name here so you don't get confused with the original one. And we'll post our code, and then let's see if it moved correctly. And there we go. So now remember the M8 was right after the G54, and now we've successfully moved it to after the initial Z movement. So that's a Fanuc controller. It's a pretty easy change, but there's a lot of things you have to watch out for. This is a very simple change on a very basic machine. Let's look at the Haas post processor, and this is where you can get yourself into trouble. So let's search for the same thing. We'll search for coolant. And if you notice in this post processor, we've got this huge if statement for coolant here. And then if we were to keep searching, we have also a similar line to our Fanuc post processor. Now why is that? Well, the reason why that is, it stems to how the Haas machine handles through spindle coolant. And if you read the manual for a Haas machine, when you turn on through spindle coolant, if the spindle was previously running, it will stop it. If you don't restart the spindle, you're going to run into problems because your spindle's not going to be turning and your machine's going to go into a cut. And that makes for a bad day. So that's what all this switch code does. If we were to look at the Haas post output with this test file that we did where we're just using flood coolant, it looks the same exact way. We could make a similar change in here. So let's find the next change. So we're going to make the same exact change as we did on the Fanuc side. And we gotta kind of search through here again. So here's our H length offsets. Here's our modal reset. And it looks like it's going to want to go right there. Yep. So we'll try to put it here. And we've commented it out up here. So then let's save this change. And then let's post-process the Haas code again. Now remember, the Haas code had it in the same spot right after G54. So we'll post-process. We'll select the Haas output this time. Ah, there we go. Okay. Just Notepad++ didn't pick up on the change. Okay, so we were able to successfully move this coolant turn-on function as well. Or did we? Let's look at this code a little closer. This set coolant guy, this subroutine is basically modal. It looks to see if the coolant is already on before it will generate a line of code. So if the coolant is not on and you call this set coolant, it will turn it on. If the coolant is already on and you call this set coolant, it won't do anything. It'll just skip on through. It won't make any entries in the output file. In the case of through spindle coolant, where we have all this logic up here, this logic is going to move this line from here all the way up to between lines 9 and 10. So it's going to move it to the place before the spindle turns on. And the reason for that, again, is how the Haas machine functions. When you turn on through spindle coolant, it's going to turn off the spindle. Thus, you need to turn it back on. So that's why this logic is here. So in this case, if you really wanted the coolant, if you were using through spindle coolant, to turn on after the Z move, you're going to have to do a lot of legwork here to make that work correctly. It is doable and it is possible, but you're going to have to move the spindle turn on to this section of code here as well. And then you have to think about, when I turn my spindle on, there's some time that's needed for it to ramp up and get up to speed. That's why they turn the spindles on up here, so that there's some time in the moving of the machine to allow the spindle to get up to speed. So if you moved that down here, then you would have to add some type of dwell to make sure that your spindle was spinning and ready to go before it entered the cut, because you're really close to the part, you're ready to go in. So those are some of the pitfalls that you have to watch out for. While this change on a basic machine is pretty simple, we just have to move one line of code to a different part in the on section. We do have to figure out where to move it, and that's where kind of reading this gibberish comes into handy, is trying to understand this stuff. But it's not that hard of a change to make. So I hope this answers some questions that people had on how we can relocate where our coolant turns on. And then I hope it also kind of points to some of the issues that you have, and you absolutely must understand how your machine works so that you can be successful while you make these changes. Hope you enjoyed the video, and we'll see you in the next one. Thanks for watching.